Welcome to our discussion today. We are going through Form 1 Chemistry end term exams. Question number 1, we are supposed to define a drug, and we define a drug as any substance natural or manufactured, which when taken changes the way the body functions. That is how we define a drug. What is drug abuse? Drug abuse is the use of drugs for purposes other than the intended ones. In other words, it is the use of drugs for wrong reasons. It also includes overdose and underdose. It includes overdose and underdose. We go to question number 1C. 1C. One of the effects of drug abuse is hallucination. What is the meaning of the term hallucination? In this case, we can say to hallucinate refers to a perception. It refers to a perception or a thinking of things which do not exist, and hallucination can be caused due to the effect of drugs or illness. We move down to question number 1D. Name 3 frequently abused drugs, or those drugs that people use for wrong reasons. 1, we have tobacco. 2, we have 3, we have miraa, also known as cat. We have other drugs like heroin. We have cocaine and many others which people use for wrong reasons. In this case, when we use drugs for wrong reasons, that constitutes what we call drug abuse. Let us go to the next question, which is question number 2. Question number 2 reads, distinguish between conductors and non-conductors and give an example in each. Conductors are substances that allow electricity, or what we call electrical energy, to flow through them. And in this case, an example, we have metals, and the metals we have are very many. We have the likes of magnesium, we have copper, we have aluminium, and others. We also have non-conductors. and non-conductors are opposite of conductors, and we can say are materials or substances that do not allow an electric current to flow through them. In this case, we have an example. Examples of non-conductors, we have materials like wood, we have rubber, etc. Question number 3. The diagram below shows the relationship between the physical states of matter. Study it and answer the questions that follow. We have the 3 states of matter, namely solid, liquid, and gas. We have process R, which is the change of a solid to liquid, and the change of a solid to liquid, we call it melting. The change of a liquid to gas, we call it evaporation. Then gas back to liquid, we call it condensation. Then from liquid back to solid, we call it freezing. But we have those substances which, when heated, change directly from solids to gases, and such substances undergo a process known as sublimation. And when such substances are cooled, they cool directly without forming a liquid into solid. And since we are forming solids, we call it deposition. Let us now go through the questions. Question number 3, part A. Identify the processes R, V, W, and U. We have already identified R as melting. We have V, which is evaporation. We have W, which is condensation. We also have U, which is freezing. Remember, freezing is the change of a liquid back to solid. Then now we go to part B. Of question number 3. Name 3 substances which undergo processes represented by S and T. The processes represented by S and T are sublimation and deposition, respectively. In this case, we are supposed to list those substances which, when heated, change directly from solids to vapor, and when you cool them, they cool directly into solids without forming a liquid. Such substances include, we have iodine. 2, we have solid carbon 4 oxide. 3, we have substances like benzoic acid. We have substances like ammonium chloride. We have anhydrous. Iron 3 chloride, among others. We now go to question number 4. In question number 4, the table below shows liquids that are miscible and those that are immiscible. We had defined miscible liquids as liquids that mix uniformly, and also immiscible liquids as liquids that do not mix uniformly but instead form layers. In this case, we have liquid L1 mixed with liquid L3 to give us miscible liquids. When you take L1 and L4, they give you miscible liquids. Then L2 and L3 will give us miscible. Then L2 and L4 will give us immiscible liquids. Use the information given to answer the questions that follow. A. Name the method that can be used to separate L1 and L3 from a mixture of the two. The mixture of L1 and L3 are miscible, and miscible liquids are separated by what we call fractional distillation. B. Draw and name an apparatus that can be used to separate a mixture of L2 and L4. L2 and L4 are immiscible liquids. And we know immiscible liquids are those liquids which do not mix, and therefore we use a separating funnel. We use a separating funnel. This is our separating funnel, or the apparatus that we can use to separate immiscible liquids. Assuming these are the two liquids, so you can see these two layers are different because the liquids do not mix uniformly. So this is the apparatus that we can use to separate immiscible liquids, i.e. liquids that do not mix but form layers. Question number 5. Give 2 reasons why most laboratory apparatus are made up of glass. 1. Glass does not react. With many reagents, with most reagents. And in this case, when we talk about reagents, we are referring to the chemicals that we use when carrying out experiments in the laboratory. Number 2, glass apparatus are easy to clean. Glass apparatus are transparent. For clear observation. For clear observation of the reactions when they are taking place. Question number 6. Name 3 sources of heat besides the Bunsen burner in the laboratory. 1. Apart from the Bunsen burner, we can use the spirit lamp. We can use a candle. We can use a kerosene stove. We can use an electrical heater. Question number 7. Draw a labeled diagram of a non-luminous flame produced by the Bunsen burner. Remember, a non-luminous flame is produced when the air holes are fully open. We know a non-luminous flame has 3 zones. It has 3 zones. That is, we have this zone here which is almost colorless. Zone. We have this middle zone here which is made up of the greenish, that is the greenish blue zone. We have the outermost which is the pale blue zone. Those are the three zones of a non-luminous flame. Remember, a non-luminous flame has three zones. We go to question number 7b. 7b, state two reasons why a non-luminous flame is preferred for heating. One, we know a non-luminous flame does not produce soot. Does not produce soot. Two, it is hotter than a luminous flame, and therefore we can say it is very hot. We go to part C of question number 7. After use, a non-luminous flame should be put off or adjusted to a luminous flame. 1, it is to avoid wastage, avoid fuel wastage. And number 2, a non-luminous flame is highly visible from a distance. We go to question number 8. Question number 8. Name 3 apparatus that are used to measure accurate volumes of liquids. Remember, when we measure volume, we have those apparatus that give us exact volumes, and we have those that give approximate volumes. Apparatus that can give you the exact volume. 1, we have the volumetric flask. We can also use a measuring cylinder. We can use syringes. We can use pipettes. We can use burettes, and many more. Those ones give you the exact volume of a liquid. Distinguish between an element and a compound and give an example of each. We said pure substances can be classified as elements and compounds, and we know from our Form 1 knowledge that elements are the pure substances which cannot be split into simpler substances by any chemical means. An example in this case, we have substances like elements like sodium, we have aluminum, we have elements like copper, etc. We also have compounds. A compound is also a pure substance. We can say a compound is a pure substance made up of two or more elements which are chemically combined. An example in this case, we have sodium chloride. We move to question number 10 very quickly. By use of a diagram, distinguish between a residue and a filtrate. We are going to use the following setup. Assuming you have water and sand. Water and sand do not mix, and therefore if you use a funnel here, a filter funnel, so this is the mixture of water and sand. Sand will remain on the filter paper as the residue. The liquid that goes through the filter paper in this case will be our filtrate. We can give an example of sand and water, and by so doing now you have answered this question number 10. Question number 11. Name the method you would use to separate the following mixtures. We have sand and ammonium chloride. Ammonium chloride is one of the substances that sublime when heated, and therefore sublimation would do. We have oil and water. Remember, oil and water are immiscible liquids, and therefore we use a separating funnel. We have kerosene and crude oil. Remember, kerosene is one of the components of crude oil, and fractions of crude oil are separated by fractional distillation. We have salt and water. Salt and water could be separated using evaporation. Also, simple distillation would do. Question number 12. Describe how you would separate a mixture of salt, sand, and iodine into different components. 1. You place the mixture in a beaker. After doing that, you cover it with a watch glass containing cold water. After that, you heat the mixture to sublimate. Heat the mixture to sublimate iodine, which settles on the surface of the watch glass. Now we don't have iodine anymore. Next, now you add water to the remaining mixture. Add water to the mixture of salt and sand. The reason why we are adding water is to dissolve salt. After you have dissolved salt, you filter the mixture, to obtain salt solution as a filtrate, and sand as a residue. After that, you are going to evaporate water. You evaporate water, or simply the filtrate, to recover salt as a solid. By so doing, now you have answered third question, number 12. Question number 13, Roman 1. We are supposed to state the function of the spatula, and we know the spatula is used for scooping solid substances, used for scooping solid substances from containers. 13, Roman 2, the function of the pipe clay triangle. This one is used for supporting crucibles, used for supporting crucibles when they are being heated. We have the wire gauze. The wire gauze is used for even distribution. Used for even distribution of heat when heating substances in beakers. When heating substances in beakers and flasks. We go to part P of question number 13. Draw and state the use of a deflagrating spoon. In this case, we are going to draw a deflagrating spoon. Here. And the deflagrating spoon in this case is used when holding substances being burnt, and we can say it is used for holding substances being burnt. Question number 14, state two causes of accidents in a chemistry laboratory. 1, it can be caused due to ignorance. Number 2, it can also be caused due to carelessness. We move down to question number 15. Define the following terms. We have solvent extraction, which is a method of separating mixtures, and we say solvent extraction is a technique used to separate different components of a mixture, different components of a mixture based on their solubility, in the solvent. We have a hydrated salt. A hydrated salt is simply a salt that contains water of crystallization. See, we have a saturated solution, and a saturated solution is a solution which cannot dissolve any more of a solute, at a given temperature, that cannot dissolve any more of a solute at a given temperature. Question number 16. State two functions of a fume cupboard as found in a chemistry laboratory. This is very simple. One, this is a place where experiments that produce poisonous gases are carried out. Two, we can also use a fume chamber for storage of reagents that produce poisonous fumes or simply gases. We go to question number 17. Explain the differences between solid and gaseous states using the theoretical model of matter in terms of kinetic theory. Remember, we have solids, and we know the solids have their particles closely packed. The particles are closely packed and only vibrate at fixed points or positions, and because of that we say hence a definite shape. We also have volume and mass. These are now solids. Then on the other end we have gases. We have gases here, and we know the particles of a gas. The particles of a gas are far apart and move randomly in all directions hence no definite shape, and volume. We move to question number 18 very quickly. Question number 18, the diagram below represents a paper chromatogram. Remember, a chromatogram is a dry filter paper showing the separated pigments. We have 3 brands of juices suspected to contain banned food colorings. We have R here, which is put on the baseline. R only moves from this point to these other points. We have this other spot which moves from here, leaving unwanted material here before it stops here. Then we have another brand here which leaves the unwanted spot here before it settles on this other hand. Now we can still move down. Having looked at that, the results showed the presence of banned food colorings in L and M only. Assuming this is L and this is M, On the diagram, circle the spots to show which brands contained the banned food colorings, and in this case, this is the unwanted spots. And by so doing, now you have answered this particular question here. Then Roman 2 of the same question, you are supposed to show the solvent front, and the solvent front in this case, you simply move some few distance from the spots, and then you call this one the solvent front. The solvent front is the farthest point reached by the solvent. 18b state two factors that determine the position where the pigments are deposited in the paper chromatogram from the point of origin. One, we base the separation on solubility in the solvent, because different pigments have a different degree of solubility in the solvent. Then number two, we have what we call adsorption, which is what we can also call the stickiness, the ability of the pigment to stick to an adsorbent material. And in this case, adsorbent materials are used as chromatograms. We go to question number 19. Classify the following processes as either chemical or physical processes. Type of change. We have heating of copper 2 sulfate. When you heat copper 2 sulfate crystals, we have a type of change which can be described as chemical change. Obtaining kerosene from crude oil, we use fractional distillation, and this is a physical change. So the figure below shows a heating curve of a certain pure solid. Remember, pure substances have sharp melting and boiling points. We are supposed to explain what is happening at the stages represented by BC and CD. BC, there is no increase in temperature. Third means temperature remains constant. Temperature remains constant as the solid melts. Remember, the heat energy supplied is used to weaken the forces of attraction holding the particles together. Then we have, this is between BC. Then we have CD. If you look at CD, we have an increase in temperature. So we say one, temperature rises steadily, and the reason why the temperature rises steadily is because the pure liquid absorbs heat energy. As the pure liquid absorbs heat energy. And at this point, we can say the heat energy supplied increases further the kinetic energy, making the particles to move faster. Making the particles to move faster. Now we move to the next part of this question, and the question says, the question we have says, on the diagram, draw a heating curve of an impure substance. And in this case now, remember impurities lower the melting points of substances, so it should be lower here, but it increases its boiling point. So this is the one for the impure substance. We move down. Question number 21. Common table salt is contaminated with copper 2 oxide. Explain how pure sodium chloride can be obtained. 1. You add water. Add water and stir to dissolve salt. Then number 2, remember copper 2 oxide is insoluble in water. You filter to obtain copper 2 oxide. Let me use simples as a residue. And after that, you take the filtrate, which is now common table salt solution. You evaporate the filtrate to dryness. You evaporate the filtrate to dryness to recover salt. We go to question number 22. Question number 22, we have the table below gives information on some substances. Use it to answer the questions that follow. We have A, B, C, D. The melting point in degrees Celsius and the boiling points are given. We are also given solubility in water. Straight to the questions. Which substance has the lowest melting point? These are the melting points, and the lowest melting point in this case is the one that is at negative 219 degrees Celsius, and this one is substance C. The one that has the highest boiling point, we have the boiling points here, and the one that has the highest boiling point at 78.5 degrees is substance A. Then we go down. Which letters represents a substance that is a gas at room temperature? A gas at room temperature, in this case, we have a C, and also we have D, because their melting points and boiling points are below the room temperature. Then now we go to part C of this question. Part C, which is a liquid at room temperature, and when mixed with water, 2 layers would be formed. In this case, we have liquid B. Then D, which substance dissolves in water and could be separated from the solution by fractional distillation? We have that one that is very soluble in water, and that one is going to be substance A. We go to question number 23. Question number 23. Give the symbols of the following elements. For sodium, the symbol is Na. For calcium, it is Ca. And for potassium is K. The last question under this. Name the elements present in the following compounds. Zinc sulfide is made up of zinc and sulfur. We have sodium oxide, which is made up of sodium and oxygen. Thank you for watching and welcome to this channel. And in case you are watching this channel for the first time, kindly take 1 second and click the subscribe button so that anytime we produce a video like this, you will automatically be given a notification.